Okay, and then this last example here is just an example of a problem. I just wanted to show you guys, this is kind of similar to what you can expect to see on your guys' test. So, starting out with, we are given f of x equals the square root of x plus 5 and g of x equals 1 over x minus 5. Okay, so first thing that they want you to do, we need to find our domain of f. So here is our f function here. What would our concern be for this one? Well, we wouldn't want to have a negative under our root. Okay, so I need to make sure that x plus 5 is not negative. So I could say it's got to be greater than 0. It could also equal 0 because 0 is not a negative number. Okay, solve that. I get that x is greater than or equal to negative 5. So negative 5 to infinity is my domain for f. Next, I need to find what is my domain of g. Okay, so finding the domain of g, what would my concern be for this one? Well, my concern would be that division by 0. Okay, I need to make sure that x minus 5 does not equal 0, so I find that x cannot equal 5. Negative infinity to 5 in union with 5 to infinity. So basically on your test, they're going to give you two functions. And the first thing that you're going to do with your two functions is you are going to, I did this yesterday too. The first thing that you're going to do with these two functions is you are going to just find the domain of those two functions. Then it's going to ask you to find the domain of g open circle f of x. Find g open circle f of x, okay? And then it's also probably going to ask you some sort of operation, like what is f plus g of x or something along those lines. Okay, but I just wanted to go over this example with you guys because this is pretty similar to what a test question will look like. So finding the domain of g open circle f of x. So remember, the first thing that we've got to find is we need to find the domain of the first thing that it's going to get plugged into. So g open circle f of x is g of f of x. So the first thing that I need to do is I need to find the domain of f of x, which we have already found. Okay, the domain of f of x is negative 5 to infinity. Okay, so we're good. The next thing that I need to do is I need to find the domain immediately after it has been plugged in. Okay, so really when I do the domain, I wish that they would ask you guys to find g open circle f of x first. Okay, so I need to find the domain immediately after this is plugged in. So my g function, if you guys remember, is 1 over x minus 5. Yes, my g function is 1 over x minus 5. Okay, so what do we have plugged in for our x? Well, we have our f of x. And then our f of x function, if you guys remember, is your square root of x plus 5. Okay, and if I look back up top here, we are just plugging in our f of x function into the f for our g function there. Okay, so that is immediately it has been plugged in. Okay, so they want us to find the domain immediately after we've plugged it in. So what would our concern be for this one here? Well, our concern would be division by 0. And just to kind of confirm, we've already addressed this concern in this part up here. So now we're just concerned about the bottom of this function equaling 0. Okay, so I'm going to set the bottom, square root of x plus 5 minus 5, and make sure that it does not equal 0. So the first thing that I would need to do, I would need to add 5 over. Square root of x plus 5 cannot equal a 5. Then I'm going to need to square both sides to get rid of that square root. X plus 5 cannot equal 25. Subtract my 5 over. X cannot equal 20. Okay, so that would be negative infinity to 20 in union with 20 to infinity. Okay? Then remember, we need the overlap of these two here. Okay? So for my blue function, I find that at negative 5 on to infinity. My red function, I find 20, but I'm not including 20. I'm including everything else but 20. So again, we need to find where the red and blue overlap and make purple. So there is red and blue in this spot here. There is red and blue in this spot here. There is only red on the left, so I would not shade anything there. Is there red and blue at 20? No, there's only blue at 20 because the red is open. Is there red and blue at negative 5? Yes, there is because the negative 5 is closed. Okay, so we would say for this one here, our domain is going to be from negative 5 to 20. I'm including the negative 5, but not the 20, in union with 20 to infinity. And that would be our domain for our G open circle f of x. Okay? Now, we do need to go ahead and simplify down here. So I have 1 over the square root of x plus 5 minus 5. And a lot of you guys are probably looking at that and thinking, okay, well, that's already simplified. But remember, we cannot have square roots on the bottom of fractions, okay? So this was a few years ago, or well, last year we did this in Algebra 2. Say you had something like 2 plus the square root of 3. We had to get rid of that by multiplying by the conjugate, which was 2 minus the square root of 3, okay? And when we did that, we found out that doing something like that allowed us to eliminate the square root on the bottom. So we're going to have to do something similar to this here. It's just going to look a little bit more confusing. So our square root is x plus 5, and our other number is 5. And for the conjugate, we're going to need to change the sign and make that a plus sign there. Okay? So we're going to do the same thing here. Square root of x plus 5 plus 5. Now, the top of this is simple. It's just square root of x plus 5 on top. The bottom, though, gets a bit trickier. You're going to have your square root of x plus 5 times your square root of x plus 5. So if I have a square root of x plus 5 times itself, that's really just a square root of x plus 5 squared. And guess what's going to happen there? It's going to get rid of the square root. Okay? Then I've got a square root of x plus 5 times a positive 5. You just end up stacking those together. That's 5 square root of x plus 5. I got a negative 5 times the square root of x plus 5. That just gives me a negative 5 square root of x plus 5. And then lastly, I have a negative 5 times a positive 5, which gives me a negative 25. Okay? Again, the top, nothing's really going on. It's just square root of x plus 5 over the bottom, though. I've got a square root of x plus 5 squared. That gets rid of the square root, like what we wanted it to do. Gives me just an x plus 5. I've got a positive 5 square root of x plus 5 and a negative 5 square root of x plus 5. Those cancel each other out. They're opposites. So I'm only left with this minus 25. And I can get down to my final answer from here. G open circle f of x equals square root of x plus 5 over x minus 20. And that is your G open circle f of x. Okay? We will do more practice problems like this. I know that seems pretty complex, but we do need to make sure we know how to do these problems.